Hello, everyone, and welcome to the June 10th professionalvmware.com vBrownbag. Tonight we're going to be talking VMware Certified Professional 6 Foundation Objective 5. We've actually broken Objective 5 up into 3 different parts because it's pretty meaty. Your presenter tonight is also your host tonight, doing all the things. My name's Jonathan Frappier. You can find me at jfrappier on Twitter. A few show notes before we get started. If you've got questions, drop them in the vBrownbag or drop the vBrownbag hashtag on Twitter with your question. I'm not going to lie, I'm probably not going to see very much of the questions tonight because I'll have both my monitors filled. But there's a lot of folks out there that will interact with you as well, and I'll scroll through after the session's over. And if there's any questions out there, I will do my best to get back to you. You can also drop them in the chat window, and I should be able to save those out to a text file and get back to folks as well when we're all done. We've got our Tuesday night Google Cloud platform series going. We just had storage last night. We've got Compute Engine being published soon as I hit the publish button on that. We've got Tech Talk still going this week at Cisco Live, our APAC show generally every other Thursday. But Al's traveling a bit right now to do the conference scene. We've got our EMEA broadcast on Tuesdays. They're looking for folks to talk VCP6 cloud. So if you've got that, you're preparing for that, reach out to Greg Robertson or myself. We can work on getting you on. We've got our Latin America show Thursdays at 7 p.m. and our US show 7:30 p.m. Central, 8:30 p.m. Eastern. You can grab past episodes of our podcast either on iTunes or your favorite podcast app, either bit.ly/brownbag iTunes or bit.ly/brownbag podcast to get those. I am all your things tonight, host and presenter Jonathan Frappier again. So with that, I don't need to make myself presenter because I'm already presenting. That's not the beginning. That's the beginning. So tonight we are going to talk section 5 of the foundation exam. And what we're going to cover tonight is creating and configuring clusters, more specifically HA, DRS, and fault tolerance, as those are enabled at the cluster level. We'll create some resource pools and migrate virtual machines with vMotion, so we'll see the requirements for that. The bit's a little heavy on slides because there's a lot to HA when you start to consider admission control and how it works. Then we'll get into some demo. We'll poke around at cluster settings. We'll turn on HA. I'll pull the plug on one of my hosts. We'll see that fail over. It takes a couple minutes, so I might hop back into slides while that fails over, being just my home lab. We'll configure vMotion. vMotion is technically section 5.4, which is after DRS, even though vMotion is required by DRS, so it'll feel a little bit out of order, but that's okay. We'll turn on FT on a virtual machine. I'm not going to power on that virtual machine because I tried that this afternoon and it completely pegged my home lab box. I've just got one box with 8 cores and 32 gigs of memory, and it was about all it could handle to not fall over. And then we'll take a look at resource pools as well. As you know, you can install ESXi on a single physical server and start spinning up virtual machines, and there's nothing really wrong with that. In fact, I've done it myself at SMBs, at companies that maybe a few years ago were anti-virtualization, and I needed a server, and I got a physical server to do that, to run that application, but you know, I'm going to stick ESXi on that box and spin up a virtual machine and consume the resources I need for that application. We've got the hypervisor, which in the case of VMware obviously is ESXi, and that's providing the physical resources to our virtual machines, so things like CPU, memory, network connectivity. On a standalone ESXi host, you'd have vSphere standard switch, which Mike Wilson covered in the previous episode. And then you'd uplink from your vSwitch to your physical network, and you might have that carved up into VLANs and have different port groups on your standard switch. which you can do even without vCenter. But where the cool stuff really starts to happen is when we pool multiple ESXi hosts together into a cluster. So virtual machines, and in my opinion, the thing that actually matters more so than the virtual machine, the application that's running on that virtual machine is still on a physical server. So if you have a physical server failure, that virtual machine, that application is not going to be available. So there's potential for downtime. But in a cluster, we have tools to mitigate the impact of that downtime. So if we were to take a look, say our host failed here. If this were not in a cluster, if it were standalone or we had not configured HA, the virtual machines would be down until you as an administrator went and took some action, or maybe you've got some other external tools that can do monitoring and some scripts to bring things back up. But with HA enabled, those virtual machines can restart on other hosts within the cluster. Now, because the ESXi hosts failed, the virtual machines, they've got their, they've basically just been powered off. There's no graceful shutdown. So they are hard powered off, and they're going to need to start on another host, which is probably a good place to say that HA is not really, or it's not backup. Right, we've pulled the plug on the virtual machine. It's going to start on another host. HA is not going to protect us against data corruption or OS corruption. So it's entirely possible that our application or our operating system was doing something when that host failed. And when it powers up, just like the operating system would if it were installed on a physical box all by itself on bare metal, it may not start, or your application may not be able to start because there could be some data corruption. So you're still going to need a good backup strategy, and Jeff Wilmington is going to cover that on either the next one of the next two episodes. We'll get into backup and data protection. So that's good for some general use cases. If it's a single application or a single virtual machine running an application and it goes down, in a lot of cases it's okay to wait the 2, 3, 4, 5 minutes for that to power back on. But we might have applications, say for like our finance team, right? We want to keep the finance folks happy because they're the ones that are signing our POs to get our vSphere support renewed and buy new hosts when we need them. So we could enable fault tolerance on that virtual machine as well, and we'll get into fault tolerance a bit as well. But that virtual machine would be available right away. We wouldn't have to wait for anything to restart. So we're going to start with HA, and then we'll roll into VMware or VM component protection and DRS. All that's enabled at the cluster level, and when hosts are added to the cluster, those resources are available for failing over and migrating virtual machines. When you enable HA on a cluster, there's an agent that gets pushed out to each of the hosts. This is not a disruptive install. You can enable, disable HA at any time. You can reconfigure host for HA on the fly. You're not going to lose connectivity to your host, or there shouldn't be any impact to the virtual machines. Once you've got HA enabled on the cluster, a master is elected, and typically the master will be the host with the most shared data stores, as data stores are going to be one of the mechanisms for detecting host outages and resolving conflicts in isolation or partition scenarios. There's an algorithm. I believe the clustering deep dive gets into the bits on how it does it. If all your hosts have access to all the data stores, who's selected as the master. But I don't think that's relevant necessarily for this exam. The master host is responsible for determining if those other hosts in the cluster, which are known as slaves, are down or partitioned. The slaves send heartbeats to your host every second, or to your master every second. And when the master stops receiving those heartbeats, it takes some action to determine whether the host has actually failed or partitioned or isolated, and we'll get into those in just a bit. When a slave failure is detected, the master is responsible for determining which virtual machines need to be restarted. So there's actually a file created on the data store that will keep an inventory of all the virtual machines, which ones are powered on and which ones aren't. You wouldn't want HA to start virtual machines that hadn't been powered on at all. Maybe they're just sitting around waiting to be deleted or used at a later date, so those wouldn't be restarted if they were already powered off. with the 2 gig memory reservation. So that's going to determine our slot sizes, and then depending on our host, this particular example from the vSphere documentation resource, one of the resource guides, VMware Availability Guide. I've got it down below. They've used the example where they've got different size hosts within their environment. So based on our slot size, on a 9 gigahertz, 9 gig of RAM host, we'd have 4 slots, right? Because I can fit, if I multiply 2 times 4, that's 8. So I've got a little bit of breathing room left over. And if I multiply 2 gigahertz and I need to get under 9, I'm going to get that into 4 as well. And then when I move over to my smaller host, in those cases, with 2 gig slot size, I'd have 3 slots on those hosts. So if I had selected this particular option for admission control, I'd be able to tolerate the failure of a single host in this particular example that they've used. One of the other options is percentage of resources, of cluster resources reserved. So this is a percent that you've defined, right? So you can say that I've got 25% reservation. So depending on what's being used or what reservations are on the virtual machines, it will go through and calculate how much resources are in use and how much are left in the cluster by taking an aggregate across your entire cluster. Again, if you've not configured any reservations in your environment, 32 megahertz is used. So our example, again, from the VMware Availability Guide, so you've selected 25%, seems about right. If you're OCD like me, you like things in even numbers, and yes, 25 is not an even number, but it's exactly 1/4 of 100%, so to me that's even. Somebody's probably making fun of me on Twitter for that one right now. But I've got resource requirements of 7 gigahertz and 6 gigs of memory from my virtual machines, and I've got a total of 24 gigahertz and 21 gigs of memory across all my math, across my cluster. See, I'm so worried about math, it's on the front of my brain. So really what we have here is we have total available in the cluster minus the total required by the VMs and then divided by the total available. So if we looked at that math, we have 24 gigahertz available. We have a requirement of 7. So we subtract 7 from 24 and then we divide again by 24. In that case, we have 70% available. We've defined a 25% reservation. So we subtract 25 from the 70 available because we're still reserving that 25%. So we still have 45% of our resources in this particular cluster. So admission control is still able to protect the virtual machines we have running and can satisfy powering on more virtual machines because we've still got 45% of the resources in our cluster available. So that's good. Admission control is not going to do that bad thing where it stops virtual machines from turning on. If we took a different example, right? Say we had a virtual machine requirement of 18 gigahertz for all of our VMs, and we subtracted that from 24. Subtracted 18 from 24, and then we divided by 24. That's going to leave us with 25% available in our cluster. Now we've defined a reservation of 25%. So at that point, we've got nothing left in our cluster. Or my first Star Wars reference of the evening, we would have a sad R2-D2 at that point because we'd not be able to power on virtual machines any longer. The last option, and there's obviously use cases for this, otherwise why would it exist, is to identify specific hosts in your cluster that will be used if there's an HA event. So if there's a host failure or isolation where virtual machines need to be restarted, that's when these particular hosts will be used. They otherwise sit idle. So even though I hate math, I would rather do math and have more hosts in my cluster available to handling the application load that I have and making virtual machines available than just having a couple of servers sitting there idle. Again, there's probably use cases for it. I've worked for companies that had HIPAA requirements and Sarbanes-Oxley requirements, and very specific customer contract requirement. So I could certainly see some scenarios where this just might be the easiest path forward to enable HA and say you've got enough resources to handle a failure in the environment. So VMCP, VM component protection. So this helps prevent against split brain scenarios where a slave becomes isolated from the master but is still powered on. This may happen more so now, especially with the emergence of converged solutions, networking, storage, traversing the same wire, FCOE traffic or iSCSI or NFS all over 10 gigs. So if that one wire is pulled, I've now lost storage, I've now lost networking. So this is a new feature in vSphere 6 to help prevent against that specific issue. So if VMCP was invoked, it'd be very much like HA. You'd have restarts if a host loses access to the shared storage system. Examples are, bad HBA or a cable or a switch port failure or some human error, or maybe zones were changed if you've got a traditional fiber channel storage in the environment. So something's happened where that host no longer has network access and no longer has storage access, so the data store is not available. VM component protection will respond to either what is known as permanent device loss or all paths down scenarios. If it's a PDL, a permanent device loss, virtual machines on the data store could be restarted on another host that still has access to the data store. It's important to note that this does not affect against storage failure here, right? So we're talking about path loss. So if we pulled a network cable or a fiber channel cable, the host is still running. We just don't have access to the storage, but the storage is still there fine. VM component protection isn't going to, it can't protect us from hard drive failures or array failures or anything like that where the data is no longer accessible. That's again going to be backup or replication or disaster recovery, all of which we will cover on future episodes. So DRS, onto that now. I'll pause for a moment, see if I've got any questions in chat. Nothing in chat, nope, good. I will get back to talking then. Questions? There's a few questions. Lost audio, hello. Hopefully y'all can hear me. Can I get a few hands raised if you can hear me? Good. Okay, that's pretty much all chat was. Lost about 12 minutes of audio. That's no good. I'm pretty sure I wasn't on mute, although I may have muted myself. We'll see on the recording, I guess. So DRS. So Duncan Epping had a good post on Yellow Bricks a while back. If you missed it, with some links out to other sites. Frank Denneman had a good post as well. So what is DRS? It's not load balancing, which was the title, or somewhere along the lines of the title of Duncan's post. DRS is just load balancing or something like that. So DRS is used to ensure that virtual machines have access to the resources they need. If a host has 50 virtual machines and another host only has 5, the role of DRS is to not make sure that those virtual machines get balanced across the host so that they each have 25 virtual machines. It's going to migrate virtual machines only if there's some sort of resource constraint. I mentioned earlier the topic seemed a little bit out of order, but DRS uses vMotion. So if you've got a host, as we do in the picture here, right, we've got 2 ESXi hosts, and I've colored the cores red to show that they were running a little bit hot. DRS, by leveraging vMotion, would migrate virtual machines to hosts in the cluster that can satisfy the resource requirements for the virtual machine. DRS it's not specifically about availability, the same way that HA and FT are. DRS isn't going to prevent against a virtual machine that's failed, or an application that's failed, or a host that's failed. That's what HA and FT are for. But it is going to help from the perspective of ensuring that your application and your virtual machine has the resources it needs to run. If your virtual machine is resource constrained, it's likely that the application could stop responding, and if the application is not responding, that's really not much different than the virtual machine being offline. So it does help in that respect. Load balancing calculations for DRS occur every 5 minutes, so it's entirely possible you might get a call that something's not responding and see high utilization on a certain host. If that just happened since the last check and it's been within 5 minutes that host has gotten really hot, that DRS hasn't kicked in yet. But there's different levels of sensitivity we can set, but it's going to do that check every 5 minutes, so just keep that in mind as well. DRS requirements. Virtual machines reside on some form of shared storage. vMotion obviously needs to be configured and enabled if that's what we are using for the transport to get those moved around. Need compatible processors, either Intel or AMD. They could be all the exact same family, exact same CPU model, or you could enable EVC, same requirements. So long as vMotion works, if you can vMotion a virtual machine from host A to host B, DRS is going to be able to move the VM from host A to host B. If you're using vSphere Flash read cache in your environment, DRS is going to, if there's a requirement for a virtual machine to have that, DRS won't be able to migrate it to a host if it doesn't have that. So that's one of those features I'd probably want on all of my hosts in a cluster for DRS to be able to properly move those around and have the host as close as possible to having the same configuration. So DRS is enabled per cluster. We've got overrides though on a per virtual machine basis. So it is possible to enable it on the cluster and disable DRS if you've got an older application that maybe doesn't respond well to any sort of latency that might be introduced with migration. You could disable it on that one particular VM, but given we're 2015 or so now, I'd expect that most virtual machines could be vMotion without any problems. So turning DRS on in fully automated mode should be possible. So the automation levels, we've got manual, partial, and fully. So manual will just give recommendations. It's not going to do anything without you manually intervening. So you're still managing virtual machine placement. You're still managing the migration. You've got to go in and take some action. Partially automated will recommend migration options. So if it thinks that the cluster would benefit, the resources would benefit by moving virtual machines around, you can get recommendations and apply those, and it will migrate the virtual machines for you. But again, like in manual mode, that's going to be something you've got to go in and trigger. But when you create new virtual machines, it will be able to place those on a host it deems appropriate on its own without you having to do anything. And then fully automated is going to do all of those things for you automatically. So when you power on virtual machines, it will be placed on what it feels is the most appropriate host. And if there needs to be a migration, it will do so for you as well. Migration thresholds you get, there's a little slider. We'll see that when we hop into the demo. You can slide that back and forth to be conservative or aggressive. I've often found that leaving it right in the middle as its default works pretty well. Some cluster considerations. So we've been talking about, started talking about HA, and then we hopped into DRS. So just a few considerations. HA can be used with vSAN. HA uses the vSAN network when it's doing heartbeats. So one requirement when you enable vSAN is that HA has to be disabled initially. So once vSAN is set up, you can then enable HA. If you've got a cluster and you've added you've already had HA enabled and you're adding local disk to leverage vSAN, you'd have to turn HA off before you can enable vSAN, and then you can re-enable HA afterwards. Your vSAN data store can't be used as an HA data store. So if you're just doing Heartbeat data store rather, so if you're just using vSAN, it won't be able to take advantage of that feature to check for host isolation or failures. HA honors DRS, and we didn't get into these too much. I probably should have done a little more on affinity rules and anti-affinity rules. So you can set rules in DRS because it's going to be, especially when you're in fully automated mode where virtual machines will be moved around. So if you think of a scenario, I'll do a little bit on DRS affinity rules now. If you've got, let's say, a web application and sits behind a load balancer and you've got 2 web servers, the point of that is generally to manage load and to make sure that it's available. So if you've got to take one of those virtual machines down, there's still another virtual machine serving your application or your website for folks coming into that. So the last thing you'd want to have is have both of those web servers residing on the same host. So you can set rules so that virtual machines will not be on the same host together. So you'd have VM1 on host A and VM2 on host B. And with anti-affinity rules configured properly, those 2 virtual machines would never live on the same host. You can also actually have, from a VM perspective, you can make sure virtual machines are on the same host. You might have a really complex application where maybe there's front-end application or web servers and there's message queuing servers, and you've got some sort of affinity between a web server and a message queuing server. You might want those to be on the same host so that they're trading traffic or information back and forth, on the host. They're not having to traverse the network at all. So there could be scenarios where you want certain hosts to be, or certain virtual machines to be on the exact same host, and you can configure that as well. And then you could also make sure that certain virtual machines are on specific hosts. So when you've got those configured, it's HA is going to honor those. But you can override it to say that HA, you could say HA must respect my rules, right? So HA is going to honor the rules. If you say VM1 and VM2 can't be on the same host and host A fails, VM1's not going to restart, because if the only other host available for it is host B, so host A failed, had VM1, we've got an anti-affinity rule that says don't let VM1 and VM2 be on the same host. If we've said HA must respect DRS affinity rules, it's not going to start that virtual machine, because then they would be both on the same host. Or you could set to should respect those rules, and HA will try to, but if it can't, it will then power on the virtual machines, and DRS, once the cluster has been restored to a working state, will fix those rules so that virtual machines are together or separate. And with that, I've got my homage to the computer gods that my demos go better tonight than they did the last time I did one of these sessions. So with that, we are going to do some demo. Yeah, I might get Josh Atwell off the hook if I dialed in, but it sounds like it might have been a voice over IP since Chris dialed in and it was working. So hopefully I didn't mute myself there, although I guess we'll never know. So let's hop into the demo. Refresh this, make sure I am logged in. vSphere web client, because that is the thing, right? Everyone loves the vSphere web client. So we're logged in here and we are talking about clusters right now. So I'm going to go and check out host and clusters. I've already got a cluster created. I've got my data center created here. In my home lab, for Star Wars fans, it's pretty obvious what's going to happen to this cluster at some point, or my data center at some point, and I've got a cluster here. So this cluster is nothing's configured on it. It's just created. Creating a cluster is really nothing more than right-clicking on your data center and saying new cluster. So I can come in and create a new cluster. and I could call this, any cluster name I want. You probably have better naming conventions for your environments. And you can see here that right when we create the new cluster, we have options to turn on DRS. We have options to turn on HA right when we create the new cluster. I mentioned DVC before, so this is used to make sure that if you've got different processor versions, remember they've got to either be all Intel or all AMD, but if you've got slightly different versions, we can enable EVC to only present features of those processors that are going to be all compatible. So we could select one of these if we had different processors in here, so that I can vMotion virtual machines between those hosts with different CPUs, which means that also DRS is going to be able to migrate those virtual machines if it needs to. So creating a cluster, pretty straightforward there. Once the cluster is created, we can still come in and manage those settings just like we would there. So we've got DRS, we've got all our options here for our cluster. So DRS, HA, licensing at a cluster level. If you are going to use vSAN, you'll have a vSAN license, and that'll need to be entered for the cluster. I'm not going to click on that because I don't remember if it shows licensing information, and I'd rather not have to do too much more editing since I may or may not have been muted for 15 minutes or so. But this is where we can enable. Let's start with HA. HA, we don't need vMotion for HA, right? So there's nothing else that I really need to enable here. So I can just go in. You can see that HA is off, and when I edit my cluster, when I edit HA, I can check a box, say turn it on. Host monitoring, this is what's going to do the network heartbeat. So obviously I'm going to need that on to ensure that my slave host can talk to the master. I can enable VM component protection here. We talked about that a little bit. That's just another checkbox. So again, if we've got all paths down or permanent device loss situation, we'll be able to protect for that connectivity loss. And then we could enable virtual machine monitoring, which we're not necessarily getting into here tonight. Admission control. So this is where we can define what type of admission control we want. So how many hosts in the cluster do we want to use? We can set that here. I've only got 3 hosts in my cluster, so in order to do some of my other demos, I'll disable this. Again, do as I say, not as I do. We can cover all the powered on virtual machines and let it calculate a slot size on its own. We can also here now define the slot size. Again, maybe you've got a virtual machine that's going to skew that really far in the wrong directions. 16, 32 gig memory reservation or so will potentially limit resources available within your cluster. This is where we can set the reserve capacity. So this is really a practice in getting to know your applications and what they're going to require, so that when a host fails, there's going to be enough capacity to run your virtual machines and applications. And then of course we can define specific hosts to fail over. So I could come in here and say I only want ESXi04 to be used for HA. So the only time that host is ever going to be used now would be during an HA event. Otherwise it's sitting there idle, not necessarily something that I want to use. And then of course you can disable admission control by selecting do not reserve failover capacity. Data store heartbeating. You have these options here. Again, you can automatically select data stores. This is the default. I've been playing around with my data stores today, so I probably tick that at one point. Or you can select the ones that you want to use. Again, if you've got a requirement or an environment where you are bringing equipment in and out a lot, maybe it's a development environment, maybe you're a service provider and you test a lot of things, maybe there's specific data stores you know are going to persist throughout all of the various work you do. And you want to make sure that those are always the ones being used. So these are the settings I want for my lab. No admission control, and HA is turned on. and I click the OK button, and it's going to reconfigure my cluster. And that is that. So I've now got HA enabled on my cluster. So I've got a virtual machine here running, and if I can SSH into that. So you can see here I've got my virtual machine running. I've logged into it. I've got a network address, and everything looks pretty swell. I'm running on ESXi 04 right now. So if ESXi 04 were to fail, this virtual machine would fail. Without HA, that virtual machine would stay off. But since we've got HA enabled, if I come into VMware Workstation and I pull the plug on ESXi 04, I am going to lose access to this virtual machine. You can see I've already lost the ability to type on it. I've taken out the host that's running on the virtual machines down. In a few minutes, we will see HA restart that virtual machine on another host. So we were on 4, we killed that. It does take a few minutes in my lab environment. I'm all nested and pretty light on resources, but if the computer gods are happy with me tonight, that should restart. So we can see here we've got something going on with our hosts. We'll give that a couple more minutes, and we'll go poke around DRS a bit while that does its thing. So DRS, like HA, we can come into our cluster and turn on. And here's where you can set whether you want this to be fully automated, partially automated, or manual. Again, this is going to be you knowing your environment, you knowing your applications, what they need, how they work, what requirements you have. If you've got security folks that allow you to do vMotion but tell you for some reason that you can't do fully automated, but you don't need change control for vMotion, tell them, maybe teach them a lesson or point them to this recording, because they're essentially just doing the same thing. I've also heard horror stories of the opposite, where security teams have allowed DRS to be fully automated but needed change control permission to do vMotion of a virtual machine. Obviously, that doesn't make too much sense since they're doing the same thing. If you're leveraging any sort of power management with DRS, or if you're leveraging DPM, you can use DRS to migrate virtual machines so that host can be powered off. I've not ever talked to anyone that's used DPM, so if you have, I'd love to have you on a vBrownbag to do some demos for us, where you can power off actual physical hosts if their resource requirements suggest that they don't need to be running. DRS will help you move those around as well. So I could turn on DRS. I'm not going to right now since I'm futzing with HA, but it's literally a check mark there. Set your automation mode, and here's your slider where you can say how conservative or how aggressive DRS should be when it's moving virtual machines around. So I've got a green check mark back on back off DRS now. I'm back onto HA. So here's my virtual machine that was on 04. We pulled the plug on 04. And you can see here now that it should be running on 05. Maybe it got a new address. Maybe it's not powered on yet. I caught it at just the right time. You can see it's working on restarting. Remember, we were on 4 before and we're now on 5, so that should come back up in just a second. Not quite there yet, though. That's okay. You can pretty much see what's going on in the background. And am I killing myself? Not too bad. Most of that's GoToMeeting, being a pig. One more try before we get back to slides. And we're not quite there yet. I'll leave 4 off for now and we'll get back into slides and we'll come check on that powering up in a bit. I had that powered on before we started tonight. So back in here. Any questions while I'm not in presentation mode on enabling HA or DRS? Nothing in chat, nothing on Twitter except making fun of me for muting myself. That was pretty awesome. All right, back to slides then. Availability guide has all of the advanced configuration options. You might have saw a few of those settings in the HA and DRS settings. You can go through, look at some of what those do. I think I listed pretty much the relevant ones on the slides here, but there's a bunch of others you can go check out as well. So fault tolerance. So we'll also need a cluster built for fault tolerance. And this lets you protect critical VMs, actually for serious now in vSphere 6, with up to 4 virtual CPUs. So there's still, I'm sure, plenty of use cases where virtual machines are running more than 4 vCPUs, but you know, a lot of SQL servers, a lot of applications will probably fall within that 4 vCPU range. So if you've got something that's really important, you can't wait for HA. You know, you needed BB8 back up a little bit quicker than it was coming back up for me. Rather than using HA and waiting for that virtual machine to boot again, we could enable fault tolerance. And it's going to create a copy of the virtual machine, which is known as the primary, and it's going to keep a secondary in sync. Like HA, this is used to protect against host failure, not VM failure. So if we think about what I just said, where it has the primary and it keeps the secondary in sync, if there is an operating system crash or error, or there's an application crash or error, or there's some sort of file corruption or security event that's compromised the primary virtual machine, that secondary virtual machine is not a backup. It's going to have the exact same problem that the primary virtual machine had. So this is really another availability tool, which has been much improved in vSphere 6, so that if I lose a host, that virtual machine is still up and running and I'm not waiting for it to restart. Some limitations around FT. So you've got your CPU requirements there. Dedicated 10 gig logging network. So because it's keeping that in sync real time, so you're pushing a lot of traffic over. I've got all of my nested ESXi hosts on one box, and when I power on a fault-tolerant enabled virtual machine, I'm basically 100% CPU, 100% memory, 100% network right off the bat. So it is a little bit resource intensive. I'll enable fault tolerance for a virtual machine and show some of the options that are available now, some of the improvements in fault tolerance in vSphere 6. I'm just not going to power it on because that would end the demo, and I've already muted myself at least once, possibly tonight. You've got a maximum of 4 fault tolerant virtual machines per cluster. So we could have, if you've got 2, right, or that's 2 primary, 2 secondary, so that's your 4. You can adjust that as well. There's an advanced configuration there. And since we've got per host, you can have a maximum of 8 vCPUs for fault tolerance. And again, that's adjustable as well. VMDKs do need to be less than 2 terabytes on shared storage for that. EVC needs to be enabled. We can't have snapshots on the VMs. We can't do storage vMotion, no link clones, no vSAN, no vVol. VM component protection is not used. If it can be enabled, but for fault-tolerant virtual machines, it will be disabled. So if you're using that to protect against all path down scenarios or PDL or that particular virtual machine for fault tolerance will not be, it will have that feature disabled. No physical mode RDMs, no CD-ROM, no USB, no MPIV, no NIC pass-through, no hot plug, no serial, no parallel ports, no 3D video. A lot of limitations, but things have improved a bit. In previous versions, what's known now as legacy fault tolerance, there were no APIs for data protection. That is now available. You could not use thin disk mode. If anyone from VMware is still listening, I'm still not happy that's name has been changed for seemingly no reason. But thin disk mode is now supported for fault tolerance, so you don't have to do thick provision drives. You can have a mix of clusters. Remember, I said before you could have EVC enabled, so that is now supported. You can enable fault tolerance on an already powered on virtual machine. That should work. It was kind of one of the, I guess, yeah, it should work on legacy fault tolerance, but shrug. And VMDK redundancy, which we'll get to, and I'll show you when we enable fault tolerance in a little bit. With legacy fault tolerance, your storage was on or your VMDK was a single VMDK attached to the virtual machine, the primary virtual machine and the secondary virtual machine. We can actually specify different data stores now, so that if we do have some sort of host and storage outage, there is a copy of that VMDK for the secondary virtual machine on a different data store. So there are some improvements, even though I had a long list of things that we can't necessarily do with FT, but there are some improvements there as well, in addition, obviously, to additional vCPU support. Back to demos. Head back over. See if that's back up. I might need to go sacrifice something else to the computer gods tonight. Oh, here we go. So here's my virtual machine that was on 4, kicked it over to 5, and it is back now. So shut this down. I probably don't need to do that cleanly, but whatevs, because I need to power back on my ESXi4. I guess I'm not going to power on that virtual machine, so I probably didn't need to. But alas, here we are. So if we wanted to enable fault tolerance, there are a few things we need to do before we can enable fault tolerance. So on our VM kernel adapter, so if we go into networking and VM kernel adapters, again, I'm just basic lab environment here. You'd probably have a dedicated separate VM kernel adapter for fault tolerance logging. You should have a 10 gig link for this, again, because you're pushing so much traffic over. You might do it with one that's dedicated. You'd have to test that out really in your environment and check with VMware support. Documentation says 10, so I'm guessing from a support perspective they'd want 10. We need to tick that box. I talked about enabling DRS, and we could do that without vMotion enabled. Obviously, without vMotion working, we wouldn't have fully automated, wouldn't be able to do its thing. We could do partially automated without vMotion, so if for some reason we couldn't do vMotion, it was disabled in our environment, we could still do partially automated mode and allow DRS to handle initial VM placement. But you'd also probably have a separate VM kernel adapter for vMotion, but I'll enable all 3 of those right here. So that has been updated. I will do that on my other hosts. This one's already done. I didn't undo this one earlier. Or did I not do that one? I did 6. Yep, 5 was all done. 4 is powered back on, so I can do this for 4 if it's not already done, which that one already is. So it's just a matter of ticking those checkboxes. And now I should be able to come in here and go to fault tolerance and turn on fault tolerance. First thing it's going to do, It's going to give us an error message, right? So I'm on host 5. As you can see up there, insufficient bandwidth for FT logging. So it's going to let me go by it. You're really sure you want to do that, because networking could be become a bad thing, but I'm going to say yes. So this is where I can select different data stores for my virtual machine, and I don't remember what data store I was on, so let's go take a look. So I am on my shared silver data store here. So when we enable fault tolerance, I will stick those on my gold data store. So I can come in here and I'll be able to select whatever data stores are available to me. In this case, I want them on a different data store, so I can just select the data stores for that virtual machine. So now I'll have my primary running on silver and my secondary running on gold. That's probably a little backwards for real world scenarios, but we're enabling this. You can see all the compatibility checks have passed. I can then select which host I want to have the slave running on. So I can see, just select the radio button for that. Again, it's going to give us an issue about bandwidth, but that's okay because we know what we're doing. And click finish. So it's going to go ahead and turn on fault tolerance for that virtual machine. We should see the icon change here in a second. There we go. And we're on host 5, and I think I selected host 6. Nope, I selected host 4. So there's my secondary virtual machine. So it would be doing some work potentially in the background to do once I power that on, it would start spinning up that the storage on the additional data store, as well as being a little more resource intensive CPU and memory wise for powering that on. So again, I'm not going to power that on tonight, but you can see here that I selected my the hosts. I've got a secondary copy on my host here, and I've got the primary virtual machine running here. And if we come, this probably isn't done yet because I haven't powered it on, but let's take a look. Nope, there's my folder ready. I was playing around earlier. So 938 or so. Ooh, I'm running long. So there is there are the files waiting to get spun up for my secondary copy. But given it's 9:39, let's get back to it. And I don't see anything on Twitter at this point. So let's talk about resource pools. Another awesome math problem for folks who are working with resource pools. So why resource pools? Well, you might have a case where you've got different groups utilizing the same set of physical hosts. We're talking about, DevOps is a big thing, IT as a service, IT transformation. So we really should be about breaking down silos at this point. So if I've got all of my hosts in a single cluster, or maybe I've got a couple of bigger clusters that different departments are sharing, I may have the need to have virtual machines all sharing resources on that host, but during times I want to make sure certain virtual machines are going to have access to resources more so than others. One example that I've had over my career is generally for like UAT and staging testing of applications before they go into production. So we might have a QA and a dev pool for certain versions of our application while they're being tested, and requirements dictate that they need to be tested in the production environment before the code can be promoted to production. So that might be a scenario where you've got resource pools for a UAT or a staging site and a production site to make sure production is going to have access to resources above what QA and dev can do. So again, we're using this to provide resources to groups of VMs. There's actually always at least one resource pool. You don't see it by default. It's just your root resource pool. So there's actually always one. Rule of one, I guess, not quite the rule of two for like the Sith have. You can nest resource pools, so you might have you might create a resource pool and then create sibling resource pools under that. You can set reservations on your resource pools, limits, or shares. You can set reservations to be expanded, and you can do this either on a DRS-enabled cluster or even actually on an a standalone ESXi host. My preference if I'm using resource pools is generally shares. I'd not want to use limits and artificially prevent virtual machines in that resource pool that might have a limit on it from accessing resources if the resources are available and if they're needed. Shares only come into play when there's contention, so as long as everybody's happy, everyone can have the resources they need, and when things start to get unhappy, then my resource pool, assuming it's configured properly with the appropriate amount of shares, will have more resources than my other resource pools. There's some default share options. There's low, normal, and high. So you'd have 500 CPU shares and 5 RAM shares for low, 1,010 for normal, and 2,020 for high, and custom, where you can set your own. Again, these are only invoked if there's contention. Reservations will make sure that there's a certain amount of resources available to that pool. Limits, like limits work directly on VMs, will limit the amount of resources that can be consumed. And then expandable reservations allow virtual machines to be powered on after a resource pool admission control check, even if the reservation is going to be exceeded. So we could tick that box. Maybe we've not given enough resources to that pool and we need it to be able to expand, assuming that there's enough resources from a HA perspective in the cluster. So I mentioned that there's more math. Did I go backwards? No. So here we've got an example, right, what we use from the first slide. So I've got a QA pool with 3 VMs, a dev pool with 4, a prod pool with 5. If I were to use the built-in shares of low and normal, right, and I've got a cluster of 32 cores and 64 gigs of RAM, I'm doing this based on memory. Right, so 64 times 1,024 would give me, times 5 would give me 327,680 shares of memory, which is pretty swell. I've got 3 VMs in that pool, so those VMs have access to 109,000 shares of memory. I move over to my my dev pool, right? QA is more important than my dev pool, and that math actually works. Right, so I've got 4 VMs in there. It's also low, so those VMs have a few less shares than my QA pool do. So if there were contention, QA would take some precedence over the dev pool. Where the math starts to come in is, right, so now I've set normal on production. Production generally is going to have more than QA or dev, I would imagine, in most cases. So I've got 5 VMs in here. It's normal, so I've got more shares, right, times 10 instead of times 5. But because I've got more VMs on a per VM basis, I'm actually pretty close to QA, not too far off entirely. So in that scenario, I might want to set that to high so that the production resources are really far and away going to have more access to resources if there's contention. Another thing to consider with resource pools, they're not folders. So I've gone into environments where resource pools have been used to group types of virtual machines together, maybe application specific. So the virtual machines in that QA, dev, and prod pool each had some purpose and they were trying to be grouped together. That's what folders are for. Resource pools are for managing access to resources. I've also gone into environments where the person who set up the resource pools knew that and they set them up properly, but over time they weren't managed. So they might have set up this low, high type example, and this happened to work on the day it was set up, but over time the production environment grew and the QA and dev pools didn't, and more VMs were being added to the production pool to the point where, thankfully, we noticed it before there ever was contention, but it was at the point where the production resource pool actually would have had less resources per VM than the QA or dev pool. So this is something you do need to manage, monitor, and keep an eye on as folks are spinning up and spinning down virtual machines in your environment. I'm going to skip the resource pool demo because it's right-click resource pool, put your shares and limits and such on, and we're running out of time. vMotion, I'll go over quickly. So vMotion again is used by DRS, so we need vMotion working in our environment in order to enable DRS to do its thing. We're going to move a virtual machine to a new host, which is standard vMotion, or we can actually move the virtual machine files with the storage vMotion to a new data store. We can also now in vSphere6 do vMotion across not only hosts, clusters, data centers, and vCenters. And the way vMotion works is it's going to perform a copy to this. While it's doing the vMotion, it's actually copying memory and everything it needs from the source to the destination, and at the last second it will flip over once everything's copied. So there is a little bit of performance impact. If you've got a virtual machine with quite a bit of memory and you're not using 10 gig network, it might take a little while to do that vMotion because it's going to have to make sure that everything in memory is ready on the destination hosts. So you can do it on 1 or 10 gig. I think at this point 10 gig is recommended. You saw where we enabled vMotion on the VM kernel adapter. You're generally going to separate traffic, not necessarily physically anymore, right? With 10 gig networking, we've probably got plenty of bandwidth, but at the very least, probably want to do that on its own VLAN as vMotion traffic is unencrypted. So you don't want that intermingled with storage or other general network traffic. It doesn't require shared storage, but storage vMotion does require that the host has access to the source and destination. So that could either be 2 shared data stores or shared in a local data store. You could be vMotioning from shared to local to do some maintenance, or local to shared to get it onto faster storage. A few considerations with vMotion. Your management IP addresses have to be in the same family, right? Either IPv4 or IPv6. You couldn't have some host on 4 and some host on 6. They've all got to match. If you're using 3D rendering, you're going to want to make sure that all of the hosts that you'd potentially be migrating virtual machines to have that same hardware GPU. Otherwise, when you move it, or it would not be able to move because it wouldn't be on the destination machine. And you can't migrate virtual machines if they're connected to local resources. Some considerations for cross vCenter vMotion. You need to be using a shared SSO environment. Could be external platform services controller, or set up in high availability, but they got to be using the same SSO in enhanced link mode. I can't believe it took me till slide 37 to mention NTP is really important. So time between your vCenters and your host needs to be in sync, and virtual machines need to be on shared storage that's accessible by both vCenters. Was going to do, I probably have time for a quick demo there. Hop over real quick. It's already enabled. So migrating a virtual machine really is as easy as right-click, migrate. You can see here we have the option to change compute resource only, storage only, or change both. So this would be my storage vMotion where I'm moving my files. This is just moving the running or powered off, in this case, virtual machine, because I want it to be quick. So we can wrap this up. I'm going to select where I want a vMotion to. It's going to do a check again, make sure that I can migrate it there. If I'm changing destination networks, maybe I've got different port groups that I need to attach to or name differently, I can change those. And I am ready to migrate. So now I'm going to migrate that virtual machine. That was a pretty quick demo, but we are 20 minutes over or so. So thank you folks for sticking around. Some more reading on this topic. So we've got the Mastering vSphere 6 book by Nick Marshall and a his crew there. Some other folks that helped worked on that. I believe Josh Atwell helped on that. You've got the clustering deep dive, which has not been updated since 5.1, but I'm sure at this point is still fairly relevant. The availability guide, which I referenced a couple times here, and is also in the blueprint for this section. The resource management guide, VM management admin guide, and vSphere read cache documentation are all in this section of the blueprint, and then of course the VMware documentation. Wrap up about me. Jonathan Frappier. You can find me on Twitter at jfrappier, on LinkedIn, or my blog verdexpert.com. Thanks everyone for listening tonight. With that, do we have any questions in? Did I lose chat? I lost my chat window. Slides were good. Cool. Hopefully we didn't actually lose 12 minutes of audio or so. Apologies for that. Twitter looks quiet. So I am going to say goodnight to y'all and see if I actually lost 12 minutes of audio on that call. If you've got any questions, you know where to find me on Twitter. If you'd like to present on a topic, we're going to be doing the VCP6 data center virtualization exam proper, not the foundation, starting in July or August at some point. We've got a few slots already filled, but I've still got a few open. So if you'd like to present on that, reach out to me, let me know. Otherwise, I'll probably be reaching out to you. Thank you, everyone, and have a good night.